So, good afternoon. Welcome to another Friday Smart Career Musings, which is a gentle flurry of interesting thoughts. And today's musing is all about the internal notion of software, the structure. And therefore, the title is Probing the Structure, What Does It Take? So, most often when we test or use a more meaningful word of probe to understand, to hypothesize, to evaluate, to come up with an approach, we always, to a larger degree, use, we take recourse to specifications, requirements, and so on, which is behavior more often. But in addition to that, we also know there is probably the way it is constructed, the internal structure. So our entire focus today is about looking how do I end up looking at it from the structural aspect? So when you look at it, it's, when we see a building and then say, okay, there is a structure. What you see is the visible building, but a structural engineer probably sees the load-bearing beams, the columns, the foundation, the steel, the metal, the joints. And therefore, he or she looks at the ability to evaluate, so to speak, or be sure that the building is safe from the structural aspect. In a very similar sense, if you kind of go on to, let's say, the idea of a doctor, and then you go with him or her with a symptom. The way you want to diagnosis is not just based on the external symptom, because doctor probably has a good understanding in the internal elements of the human body, the various systems that are there, the skeletal system, the vascular system, the nervous system, the variety of systems, the various parts that make up the body, the various connections that they are, the various interactions that they do, and therefore you use the internal structural knowledge to probably figure out a potential diagnosis for a given system. I guess we're talking about the same context with respect to software. So we all know that a software has some internal structure, internal elements. They're more often invisible, but they're very consequential in terms of how we look at the act of evaluation, or to use a more larger word, a better word, maybe just the act of probing. Right? So all I wanted to muse about is, so how does one probe, if you will, the invisible? I know we use variety of standard terms. The intention is to use beyond the typical standard terms. And that's what the next few minutes are probably structured around. So, if you look, we all know about the behavior, right? What the system does. It is what the manifestations are, which is what we observe. So we use the external facade in whatever form. Maybe it's a UI, maybe it's not a UI, but the place at which we interact. Right? And that's what it is. We observe and therefore judge based on what we see, what we input, the intended behavior, and then say right, wrong, good, bad, etc., or may explore and understand. But behavior is what the system does. The structure is what the system is, right? So one is, in a way, the outcome, a manifestation. The other is what it is. And they are not the same thing to probe. And that's what we're going to do probably is to look at the latter part, the structure. So we all know, to put the context in place, we all know that some issues are not necessarily because of the way the spec is written or what has been told as requirements. They are born in the act of construction. And the construction here is about design and code and implement and so on. And that's where I think more often than not, it is a lot of interesting design choices that we make in terms of an architecture, the way we use the various elements that we use, which are not really our code, libraries, frameworks, subsystems, and so on. And they all connect with each other in very interesting myriad ways. They're seemingly invisible, ubiquitous, but they're very consequential in terms of what outcomes are. right? And therefore, issues that happen are not necessarily because of what was stated as spec, or what was probably misunderstood in terms of a spec, or what was missing in terms of a spec, and therefore manifest in the behavior because of what was said. It's more often that it was built, right? So it is invisible, largely. So when we look at the structure, I think there are two facets to it. One, I as a developer, and I as a person who's validating the tester, the guy who's actually probing. So when I think about the structure, let's say as a developer, I'm more interested in saying, how can I pay more attention to the innards which make up the system, to what I'm building, and how do they have a bearing in my delivery of the behavior, my subsequent maintenance of the system and upgrade the system as I go forward, and of course, the correctness of the behavior, right? Whereas when you look at it from the viewpoint of a tester, I guess what we're trying to say is, okay, there is a lot of stuff that is inside, in whatever form or fashion, which we shall explore in a few minutes. And the intention is, how does one probe that? Things that are invisible. And is there a process? Is there a practice? Is there a tool? How do they come about in this act of probing the internal structure? So one of my interesting favorite questions that I used to ask when I used to kind of teach, if you will, the idea of white box testing to people, I used to give a small example to illustrate that idea. And it was as follows. And that sets the tone for the next discussion on what is structure. So I used to ask, here is a big building. Maybe it's an apartment. Maybe I'm living in this apartment. Maybe the building is new or old or whatever. And then I asked that question. They asked the person who's living in the apartment, say, hey, do you know if your house will develop a leak? And I've heard very interesting answers. And the intent is not the answer. It is the reasoning and the questioning behind the answer, the act of probing to find the answer, right? So some people have told me, no, it won't because it's a new building. Some people have told me, no, I've been living in the building for a long time. It has not leaked, so I don't know. Maybe it will, but up till now it hasn't. Somebody else has told me, well, I don't know. I can't see anything. And some people have gone further and said, I need some extra information. And then I asked them, what information do you need? Because leak is not just because, the window sill is leaking and the water is coming, or it is on the top floor and therefore it's leaking through the floor. It could be very many. So some people have asked me and said, hey, can you share with me the piping diagram? Because leak is not just due to coming in from the window or coming in from the top or a crack. So I want to know maybe a few other things. So in addition to the building plan and the materials that are used, I would also like a piping plan. That's kind of interesting because they're trying to find out, okay, there is an hypothesis that he or she is making that the water can leak from very many sources. It could be cracks. It could be, maybe the cracks in the windows or cracks in the walls. Or it could also be internal leakages, which I can't see, which is coming from the pipes. And therefore, if I go dig in further and then say what kind of pipes, when were they laid, and so on and so forth, then maybe you could start probe to find an answer in a little more logical fashion. That is where structure comes in handy. It helps us to appreciate and understand, and therefore make a more informed choice into what we can do, right? And that's where we start off by asking, what is the structure? Is it as simple as saying module, code, algorithm, resource, coverage, or schema, formats? Maybe all of them. But then we have to kind of synthesize a meaningful probe, connecting all of this as we go forward, so that we could find a more appropriate piece of information to help us understand, hypothesize issues that you want to look at, formulate an approach. So structure is not just code. It's not just an algorithm. It's a very rich, multi-dimensional thing. Most of us probably look at it sometimes from a myopic notion. And it's a fairly expansive stuff. So is it code? Maybe. Is it data? Yeah, there is a schema, there is a structure. Is it interface? Yes, it is. Because there is a structure to the interface, there is contracts on the interface. Is it the way the various elements of a system, which is partly code structure, which does some processing, which takes in some inputs, collecting to various data sets from a particular format, but they are not individual, they're coupled, they're connected. Is that a structure? Yes, it is. It's like the joints, it's like the bends of a pipe, right? So the system could leak if not because the pipe is broken. It is because there is a bend, and in that bend, the joint is given away. So maybe the coupling is a problem. It's not the pipe itself. Is it about the internal states of the system? Maybe. System where it's come into a state where it is saturated with work. Maybe it is run out of steam and therefore it's starting to fail. Is that a state? Maybe. You could consider various kinds of states, right? One state that we all easily appreciate when it comes is in the context of performance and load, because we say, oh, it's pretty saturated. But state is not just limiting to load, right? There are various states. Could be in a state, there's a state where it's vulnerable. Maybe where it's a state where it is doing two things at the same time and they ultimately have to merge. So there's a transactional and so on. So is it code? Is it data? Is it interface? Is it in the coupling? Is it in the states? Or is it pre-code, the architecture? Or is it beyond just the architecture of my system, which is my piece of work that I'm doing? Is the overall solution architecture, the way systems are put together, connected, deployed. And that's what we want to look at, right? So set the stage for you in terms of how to look at it, and therefore say, maybe these are all the various dimensions, facets, elements, parts, whatever you want to call this, which we will outline. And then say, how can I synthesize some interesting probing questions to be able to dig in? So keeping this in mind, let's dwell, and that's really the core of this, if you will, this music. So expounding on the same question of what is structure, let's give it a little more structure. Flesh, bones, systems, like what the human body is, right? So the various elements in the human body, and of course, the various systems that are there, they're beautifully interconnected, and that's forms the internal structure, allowing us to do amazing behaviors. So what is a structure? You could consider it is made up of maybe various elements of maybe differing types. One element is data. Another element could be a processing element, which encodes the notion of algorithm, the actual behaviors displayed by the code. Or it could be the way by which elements are connected, data flows, maybe an interface. So there could be a data which could be deemed as an elemental structure, like a data structure, as we all know, at the lowest level, at the highest level. And that's where the second thing of granularity comes. So when you say this is a stack, and when you say this is a queue, and when you say this is a list, and so on, they probably are meaning from a very low level, fine level data structure. You elevate it and look at it as a file made up of records or database or something more larger. You move in from the fine structure of data to a mid and a coarse, meaning higher levels of encapsulation and therefore higher granularity. By the same logic, if you look at it from the element of processing, you might say this is an algorithm, and therefore we are probably converting the algorithm into code, and therefore we use certain words like code and coverage and so on, and therefore we consider it as elements of structure. And then you might encapsulate that mode, the set of algorithms or set of pieces or set of code, and then you might call it, for lack of any better name, module, component, task, system, subsystem, and various words, which all indicate a notion of fineness, coarseness, a granularity of the type. The same thing, you might look at it from an interface. You might talk about it as set of packets going in a particular order. There is a handshake. And then you might ultimately elevate it into a series of packets which does a particular job, which is one transaction followed by another transaction. And therefore, the interface also has a sense of granularity. So I just want to kind of set the first idea of a structure as saying it's probably various elements, two of which we all know, made very famous by a book very, very long ago by Nicholas Wirth, which was titled as, data plus algorithm is equal to program, which I know is probably Nicholas Wirth, by the way, was the developer of the language called Pascal, and it was one of the classic book when it was printed and listed a few decades ago. And all it did was to say, hey, data plus algorithm is program. So same idea I'm kind of borrowing by saying data, processing, and the interface which connects the various elements at a higher level is one notion of type. They could be at different granularity, and therefore that is one facet of a structure. They are not individual, they are all coupled, right? You don't have individual pieces. So you have data which is coupled, and ultimately you have a set of data or a set of modules or a set of processing elements, a set of interfaces. So again, there is a notion of coupling, right? Which when we go back to classic software engineering, we understand there are connections, and ultimately our entire system is one giant connection, which in a very classic notion of programming, we always talk about it as a main, and then you keep on looking at it as the main has the main control and so on and so forth. Again, the classic simple notion of a program. So why does coupling become important? Because they are not individualistic. Of course, today in the newer architectures, like microservices and so on, client-server architectures going all the way to. So we have tried to decouple. Why? Because decouple seems to be less risky, gives us more advantages in a variety of different ways. But what we're talking about in this context is there are elements of various sizes, and they are all interlinked and connected, maybe tightly, maybe loosely, maybe some of them are not easily visible, but then broadly tight and loose. And classic software engineering tells us there are various kinds of coupling. And there is some kind of a notion of an arrangement, maybe in a sequence, maybe within each other, maybe in some form. So the sequence may be described in various words. You might say this is a pattern at a processing element level, or an interface level as a pattern, or you might say format like a data. So what we're saying is it is not just elements and connections, but there is also some kind of an interesting arrangement. And that arrangement is also part of the structure. And each of these, whether it is a data element or a processing element, seem to have certain inviolates. They are bound by some kind of a contract that this data structure should have these elements, and these are mandatory, and these cannot be empty, and so on and so forth. It should have a certain representational format and so on. Or you might say, look, when this particular processing element is alive, then the system state should be this and not that, and so on. So there is a notion of an inviolate or a contract, which is either declared or implicit. And what we might want to do from a probing perspective is to find out, can they ever be broken, right? And that's the notion of a contract. And so the elements of various granularity, which are not independent, but which are coupled, which have a certain arrangement when they are coupled, each of which has to satisfy certain inviolates, may exist in various states of operation. Data may be in certain state. The processing element, so to speak, the module or component or task or procedure, whatever, may be in a particular state. So we're talking about it and saying, if I add in the idea of a state, then, how can I use that information to probe? So you might say, at this point in time, this is the state, and if this happens, would I break the contract? Would I break the structure in terms of a coupling, and so on and so forth? Those are the questions that we will probably ponder. So I'm just trying to list down the various facets of a structure. Now, by the way, the various elements of various types of granularity which are coupled, put up in a certain arrangement, forming a contract in a particular state, displays some characteristics. What do you mean by characteristics? That particular stuff is probably very rigid and therefore very strong. But if you bend it too much, it will break. Or it is very loose. It is very malleable, so it can beautifully adapt. So maybe here is a processing element is not very rigid. When it's subjected to a lot of operations, it understands that it is reaching its system limit of how much it can process, and therefore it spins off another thread or spins off another task or does something, and therefore automatically scales. Or here is a piece of stuff that, it is encountering some data that is probably incorrect. It's probably trying to ascertain if the data is some kind of a vulnerability, and therefore suddenly, some sense, adapts to it by healing itself, closing it, does something. So it's not a very rigid way by which it handles. So be it in the context of data, which is highly structured and therefore maybe very rigid, to a little more loosely stuff, and therefore which we process, which is looser, so to speak, or we are looking at it from a characteristics of rigidity, fragility, ambiguousness, from looking at the view from data processing interface, and see that could yield us some information to help us dig in and probe better. And what do these characteristics, arrangement, contract states have? Well, they have probably at the end a result on the various systemic attributes like performance, scalability, security, maintainability, testability. Of course, we're looking at more often the non-functional attributes, because they are really what a structure ultimately manifests itself as. Right? And not to forget that all these elements that are there are consuming certain resources: computes, memory, bandwidth, tokens, handles, threads, software resources also. So I'm trying to kind of put together this. I'm trying to muse about and think of a structure and say, when somebody says structure, hopefully it is not just a piece of code, just a data or a format, and say, oh, here is a schema for this, or a structure of a file as in terms of a JSON, XML, or a format like a JSON and stuff like that. I'm trying to look at it from maybe types and granularity and coupled and so on and so forth, and use this idea to maybe probe. So we'll get to that probing in a bit, but I want to ideate on the fact that, hey, the structure is something that's fundamentally hidden, like the roots, like the soil, the various layers, the texture, etc., right? All which is hidden, and what you see is the beautiful green leaf outside, the tree and the plant and the fruit. So think of the structure as, the rooted stuff within the soil, which has various characteristics, and they ultimately deliver, quite obviously, the system quality attributes. So we can't always sit and evaluate and test each of these as much, because it is kind of complex. So we're trying to probe one part intellectual probe, second part physical probe, and understand that this act of intellectual probing helps us to understand the connection maybe to the ultimate attribute, and therefore the bearing it has on the expectations of the system that we deliver, and understand that the structure ultimately makes these properties very emergent. You are not adding anything. The way the elements come together ultimately make some of these emerge. And therefore, they are felt by users as performance and security and resilience and so on and so forth. They are felt by the builders and developers and the maintainers as maintainability, testability, changeability, observability, and so on. So it is only natural, therefore, that any structural decision that we make, decisions regarding the structure, as an architect, as a developer, more often the builder, if you will, affect in some sense the quality of the life of the system. So I can't be immune to that as a person who is trying to validate. It is quite imperative for me to appreciate and understand. But then I should not necessarily be overwhelmed by the entire notion. Oh my gosh, the structure is too complex because system has so many layers, so many third-party tools, so many subsystems, so much of baggage of code that is inherited, gazillion states deployed. And that's really what a complex system is going to be. How do you dissect to be able to prove? That is what we are probably using. And do understand the structure is not just in terms of realization of code. It exists in models, architecture, diagram, data model, contracts, intent, assumptions. But they're all probable. This is what we normally can manifest and see it in the realization as code, as schema. And what we're trying to look for is probably, in some sense, the gap between the model and the realization. And that is where the structure, in a way, hides. And before we get into the probe, I just want to leave you with another thought. So with the thought one was, don't forget they exist as models. Certainly they exist as code in whatever form as realization. But not to forget the fact the structure also has a life cycle. What do I mean? I build something, and then I modify, I adjust, I remove. I kind of drift along because something else changed. So when we are talking about the structure, it is not something that is static. It is alive. It is constantly being buffeted, changed. You can't look at a building and say the building is just static. No, it's a tall building. There are winds. Probably it's quietly shaking, but you may not notice it. Maybe there are tremors under the ground, you may not shake it. Maybe there are things that are going down the various tubes and the ducts in the system, you don't know. There is probably electrical stuff that's happening. So there are waves, the electromagnetic wave, they're probably affecting. So what we're trying to say is there is a dynamic nature of the system. And therefore, when we probe, we're not looking at it from a static sense. We want to also understand as the system is morphing, changing, straining, shifting, etc., we want to also probe from that angle of life cycle, right? So keep that in mind. So now let's try to kind of come to probably, in some sense, conclude and say, how can I probe? Is there a very well-formed, here is my checklist, can I do? No, it doesn't probably work that straightforward, right? So we'll probably have a compass which guides rather than a perfect map that I have. So the probing compass is kind of using the same idea of what we started off with when we talked about the structure by looking at it. So saying simple questions that we are asking for is, okay, what kind of elements do I see? What are data elements, processing elements, interface elements, so that I can form a mental picture of the various elements and be able to appreciate as to where the granularity is, it fine, coarse, etc. So this is a very simple set of questions, if you will, which form the compass, which looks like a very simplistic checklist, and just asking questions at an elemental level. How is the coupling? Where do I see coupling? Where do I see states? What states do I see? What kind of contracts have to be held forward at various elements of the system? And they are individualistic questions, right? What kind of formats, patterns do I see? Oh, this is implementing a publisher-subscriber. This is implementing some transactional pattern. This is inventing a state pattern. At whatever, anti-pattern, pattern, etc. Various levels, right? Could patterns, formats, etc. Oh, what of it is what kind of a model? So I'm in the process of implementing something. So I have a model. I have an architecture model. I have not yet realized. So there are both of them are possible, right? Because everything is not implemented. Some we're doing it earlier. And then we're keeping in mind that, okay, what is new, what is changed, what is adjusted, and so on. And then keeping the last notion of there's some characteristics and attribute. So we're trying to, in some sense, decompose the fairly complex structure of a system that is in existence, which is being modified, or that is being constructed afresh. And we are looking at it from this and then trying to ask a connection set of questions and then say, okay, if this is the element, here is a processing element that's implemented as a particular cron job or will be implemented as a particular cron job as a task. which is at a mid-level granularity. How is it coupled with the other elements? What kind of states are in place for it? What kind of data does it process? What kind of interfaces exist? How tightly coupled is it to other things that is up there? In the context of our business, would that tight coupling be necessary, or can I make it loose? So we're trying to not look at individual elements as parts of the compass, but the collective notion of connecting the type to the granular, to the way they are linked, the way it moves. So both the static notion and the dynamic notion, and string a particular question as a probing question, and then dig for potential answers, some of which may be available, a lot of which may not be available. And that is how we are probably trying. So each of these facets is a direction to shine. Combined, they give you a territory. And therefore, that brings about the idea of a journey, right? So you're basically journeying through the structure to probe. And what is the intention of probing? To probably understand it better, to have a more clearer idea so that you can formulate a better approach. Maybe to hypothesize potential issues and therefore set up a more clearer criterion what I'm going to look for. And if there are manifestations of an issue that have been noticed as a bug or an issue or a customer reported issue, then I'm trying to use this idea to do the backward notion, the analyzing why, and therefore look at if there are any structural adjustments, improvements that I have to make to be able to fix some of these issues and probably fix certain recurrence of certain issues. Right? And lastly, asking this entire question, okay, is it a process? Is it a practice? Is it a tool? What makes the structure visible? What makes us as developers and testers to pay attention, to probe deeper? Is it practice? Is it process as tools? I won't answer this because I'm sure all of us are wise enough to figure out that it is neither of those. Certain tools help us to look at the internal structures. Certain practices help us to appreciate better. Certain processes allow us to prevent and do on the direction. So in a summary, and if you were to sum it down to a particular slide, this is how I would look. We started with this idea that behavior is what a system does. The structure is what a system is. And then we kind of went into a little bit of a detail in terms of elements, granularity, connections, contracts, attributes, characteristics, and so on. And therefore looked at what we might have seen as the invisible, ubiquitous nature of the various elements. And then said, maybe all I need is some kind of a compass to look at the individual pieces and then journey through them by trying to connect. And in the process of journeying, probably more interesting probing questions emerge. And that is probably what it takes to probe. So we shine the torch from different angles and hopefully try to see a more larger picture. But then there will always be some shadows, which I think we will as we change the angles of the torches. Shadows don't go away. Shadows exist. All you're trying to do is the best of the ability to probe the structure of a system and therefore probably do a far superior job of construction on one side and also validation on the other side. I hope it prodded you to think on a structure a little differently. It is an area that I always find fascinating, more so because we've got more interesting, complex technologies, various frameworks and tools today. And it's one of those that you can't answer in a very straightforward, simple stuff. So that is what I thought may be interesting to use. So thank you and have a great day and have a lovely weekend. Thank you so much. Some of you probably seem to resonate with the idea here. So thank you for your hand waving and claps. Appreciate that. Have a great day.